Alright guys, welcome to the 3-1 notes on graphing linear equations. This is a really important unit, so hopefully you're focused, you're ready to learn. This is a really important thing that comes up over and over and over again in pretty much every math class you take from here on out, being able to graph lines, being able to graph correctly, and we're going to focus today specifically on lines, but some of the same concepts overlap into other areas also. So, some things, all right? A linear equation, okay? A linear equation is an equation that forms a line when it is graphed. Sometimes the easiest way to tell that is just to actually use our graphing calculator to see if we get a line, and I'll show you guys how to do that this unit. Linear equations are often written in the form ax plus by equals c. This is one of the hard parts of this unit, is that there are different forms of things that we have to know, okay? And this just happens to be the first one, okay? So standard form is something that we're going to have to be able to use and understand. So standard form, it's ax plus by equals c. Okay, c is typically referred to as the constant, or it's just a number, and ax and by are both variable terms. So some key things here: a has to be greater than 0. Okay, that's one key. A and b are both not both 0. That can't work. And that they all have to be integers, okay? So no fractions, no decimals, okay? No fractions, okay? We can't have any fractions in this form. All right, so let's take a look at identifying linear equations. So just understanding when it's a linear equation and when it's not is going to be incredibly useful. So, yeah, sorry about that. So take a look here at example 1. We have an equation y equals 4 minus 3x. Okay, so y minus 4 equals 3x. We want to rewrite the original equation to see if we can get it into standard form, okay? And if we can get it to look like this, like ax plus by equals c, then that equation is going to make a line, okay? Take a look at part B. Since the term xy has two variables, if any term has more than one variable, it's not a line. Okay? Any term has more than one variable, it's not a line. So that might be worth writing down. Okay? Any term has more than one variable. It is not a line. Okay, let's look. We'll look at these together. First, could we get that? There's no x, so you might notice that right away. So there's no x, but in the rules, it said we could have, a b value of, or sorry, an a value of 0. What if we got rid of the fractions here? We multiply both sides by 3, and we get y equals negative 3. Okay, that is a line. The line y equals negative 3 is something that we have seen before. That is a line. Okay. It's in the form, and even though there's no x, ax plus by equals c, okay? It is in that form, just a is 0. And then let's take a look at 1b. 1b, we should notice something right away. The x has, it's squared. The moment there's an exponent on anything, it's not a line, okay? Not a line, okay? So this one is a line. 1b is not a line. All right, let's take a look at, oops, sorry about that. Okay, so a linear equation can be represented on a coordinate plane graph. The x-coordinate of the point at which the graph of an equation crosses the x-axis is known as the x-intercept. That's pretty self-explanatory. And where it crosses the y-intercept, y-axis is called the y-intercept. These two pieces of information are really useful when drawing a line, because to draw a line we only need 2 points. All right. The y-intercept is whenever the x is 0, and the x-intercept is whenever the y is 0. All right. So, for example, looking at this one, if we were to find the x-intercept and the y-intercept of the line at the right, so the y-intercept is where it intersects is where the line crosses the y-axis, which happens right here at 30. So we're looking for a y-intercept of 30, so we know it's not that one, we know it's not that one. The x-intercept is right here where it's 20, so we know the answer is B. Okay, easy peasy. Let's not overthink these. Let's take a look at this one. Find the x and y-intercepts of this graph. Well, the x-intercept, guys, look, this starts here and goes forever in that direction. There is no x-intercept. Okay, the y-intercept is right here at 150. So we go through these. It's not 0. X-intercept 0 implies that it crosses right there. So it's not that one. It's not that one. It's not that one. We know it's J. All right. Let's take a look at a real-world problem. A swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of the water in the pool and the time and hours that the pool has been draining. Okay, so it started after it had been draining 0 hours. So before we started draining it, it had 10,080 gallons in it. And then every hour it loses 720 until at 14 hours there's none. All right. So find the x and y intercepts. Well, the y intercept is when x is 0. Okay. So the y-intercept is 10,080. The x-intercept is when y is 0, so that happens at 14. And then describe what the situation means. This is where we got to put this into sentences. The x-intercept at 14 means that after 14 hours, there's no water left. That's all it means. And the 10,080 means that before we started draining it, that's how much water was in the pool. Easy, no problem. Let's take a look at number 3. All right, so find the x and y intercepts. So time is x, distance is y. So the x-intercept is when y is 0, and the y-intercept is when x is 0. Okay, so the x-intercept here is when y is 0, so that's 4 hours. Okay, the y-intercept here is at 248 miles. And then describe what is happening. This is the distance to an amusement park driven by the Torres family. Okay, so if you wanted to describe this, at 0 hours, their distance left is 248 miles. So that's how far they live from the park. They live 248 miles from the park. How long did it take them to get there? It took them 4 hours. Okay. Yikes. All right. Now let's look at how we're going to graph these. Okay. Let's look at how we're going to graph these. A really simple way of graphing lines when given in standard form is to use the intercepts. Okay, so I can find the x-intercept, I can find the y-intercept, I put those 2 points down and I can graph. Okay, really simple. The explanation here is to find the x-intercept, to find the x, make y equal to 0, and to find the y, make x equal 0. Okay, that's as simple as it can be put. All right. So this is important. Write that down. Put a star by it so you know. Okay? So on this first equation that we're given, we're going to find the x-intercept first, so we make the y value 0. 4 times 0 is 0. 0 plus 2x is 2x. We divide both sides by 2, and the x-intercept is 8. Okay? X-intercept is 8. Then, to find the y-intercept, we let x equal 0. So x is 0. We plug that in. We get y is 4. So then on a graph, we can just go to y is 4, x is 8, put a line, and I got it. Okay? Lines, make sure we have arrows on them, and they go forever. If you don't have graph paper, by the way, that's fine. You can just sketch these out. Okay? So let's take a look. Let's get a sketch of 4A and 4B. Pause the video right here. Get these on your own, and then I'll walk you through them. Pause the video now. All right, so you've unpaused. Let's take a look at this problem here, 4A. So let's find the x-intercept first, and then we'll find the y-intercept first. So I'm going to find them both first. We'll find one of them first and one of them second. Okay. So the x-intercept for this first equation is, so the x-intercept, I'm going to make y 0. Okay. So then I get negative x equals 3, so x equals negative 3. Hopefully that's what you got. To find the y-intercept, I make the x 0, and I get 2y equals 3, so the y is 3 halves. Okay, then on a graph, on my sketch of a graph here, I would go to 1, 2, 3 on the x-axis, and then 1.5 on the y-axis. And again, that's just a sketch, but it doesn't have to be perfect. And that's my line. Take a look here. To find the x-intercept, I make the y 0. Okay, so x ends up being -5. And then the y value, I make x 0. And I get y is -5. So then here's my sketch of this one, and I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and here's my line. It's nice and yuck. Important thing to note that example 4 has both an x and a y-intercept. Some lines have an x-intercept and no y, and vice versa. These lines look like this. So anytime we have y equals a number, it's a horizontal line. That line is never going to intercept the x-axis. And the opposite can be said for x equals any number. X equals any number is a vertical line. Some of you may have heard this term Hooy-Vux, and we'll talk more specifically about that later, but it talks about how horizontal lines, it refers to their slope, which we'll talk about later, but that they are written y equals a number, okay? That's something that you just need to memorize. X equals any number is a vertical line, okay? And y equals any number. That's a number, not a hashtag. Okay, that's a horizontal line. No matter what. Okay, no matter what. All right, let's look at how to graph making a table. Making a table is the most effective way to graph from here until calculus. So graphing a table is a hugely important skill, and it works like this. You give yourself, and most of the time you won't see all this stuff. You'll see, when you guys do it, you'll do this. It's an XY chart. And these numbers here, these are just numbers from your brain, okay? The students get caught up on like, well, where did you get those numbers? From your head. Now, these were picked intentionally because the fraction here is 1/3, and we didn't want decimals because it's tough to plot decimals. So we picked factors of 3. But really, you make a table, and you put in some numbers for the x. You solve for y. That's your number for y. And then you get points that you can plot, okay? So let's take a look. I'll work on 5A with you, and then you guys can do B and C on your own, okay? So let's look. So on 5A, we get ourselves a table, so an x and a y. And, you know, you just want to pick a few numbers. I think -1, 0, and 1 are good numbers to pick. So -1, they're small, and 0 is always easy. So when we make x -1, we end up with -2 minus y equals 2. I add 2 to both sides, and I get -y equals 4. That's a y, goodness. And then so y equals -4. So if I'm graphing this, I know at -1, -4, somewhere about there is a point. Then I'll make x 0. Okay, so now x is 0, so then I just get 0 minus y equals 2. And so when x is 0, y is -2. Okay, so then I would go 0, -2, and there's a point. What about when x is 1? When x is 1, we get 2 minus y equals 2, and I end up with y equals 0. So I have that. So this is what my line looks like. Okay? No problem. Let's take a look. I'm going to go ahead and walk you through 5B and 5C because those are the tricky ones. No matter what number I pick, here they're telling me x is 3. Okay? And when they tell me x is 3, literally all I have to do is go x, I find where x is 3, and x is 3 at every single y value no matter what I pick because y isn't a part of the equation. X equals 3 is a vertical line, that's not a very good line, through 3 on the x-axis. The opposite can be true for y equals -2. So I go to where y equals -2. And y is -2 everywhere on that line. Okay? No matter what I pick for x, because x isn't a part of the equation. Y equals -2 looks like that. Alright? That's it. Okay? That's it. If you want to try a couple of these, go ahead and try a couple of these as you finish the notes. This is in your book on page 157, okay? In your book on page 157, 1 through 11, or 1 through 12, try some of those, and I will see you next time. Bye.